I have looked at the illustrations from GeoGebra, and I'm finding that we don't have 100% success on creating the altitudes for the obtuse triangle yet. So this is important. Sit back, listen, use the definition of altitude, and let's get this straightened out. Altitude is simply another word for height, so we can use the term altitude or height. For a triangle, it is a line at right angles to a side and going through the opposite corner. So that's vertex to side, where the right angle is where it hits the side. Now that's pretty easy to manage in a right triangle because the altitude is simply one of the legs. And it's pretty handy in an acute triangle because the altitude lands inside in each case. In an isosceles, the altitude will also be the angle bisector and the segment bisector. But when it's obtuse, the altitude will land outside the triangle, which is why we include the words line that contains the side of the triangle in the definition for height of a triangle. So let's see if we can find an official definition for height. That seems like a long download, so I'm sick of it. Let's try openreference.com. Altitude must be one corresponding to the base you choose when you're finding the area of a triangle. So we need to know how to find each altitude because we might be given a base that requires us to find the altitude that's outside the triangle. Measure the altitude at right angles to it. You calculate the area you pick. To calculate the area, you pick one side to be the base and then measure the altitude at right angles to it. An altitude of a triangle is also a line which passes through a vertex and is at right angles to the opposite side. Now, this really should say to the line containing the opposite side, because when we look at the obtuse, it doesn't hit the opposite side, it hits the line containing the opposite side. So on GeoGebra, let's start with an obtuse triangle. And I don't really need the axes here, so let's turn them off. In order to create an altitude, I need the line through a vertex that is perpendicular to the opposite side. Well, for the obtuse angle, that's easy. The altitude is going to land inside the triangle. Altitude, just another word for height. The height is going to land inside the triangle. So there is the height from vertex B So let's add a segment, and let's turn off the long line we used to trace it. No. Let's add that segment again, and let's make it a dotted segment. And let's give it the name H. Okay, so it's named H. Now I need a segment from A to the line containing the opposite side that is perpendicular to the line containing the opposite side. Well, let's just snap a ray through here to extend the opposite side. And that's because we need a line perpendicular to this. That's not going to land inside the triangle. So let's just change the color of this extended line. And now let's find a perpendicular line through A to the line containing the opposite side of the triangle. Let's put a segment. Oh no, first I need a point of intersection. Then I can just add the segment, turn off the long line, and dot this. So there are two of the heights of this obtuse triangle. I need a third from point C to the line containing its opposite side. Now the opposite side is AB. That's the side that doesn't share a vertex with C. But the only way to go perpendicular to line AB is to extend it and consider the line that contains segment AB. So let's add a ray through AB to extend the line that contains segment AB, and let's change the color of it. And use the perpendicular line tool to go from point C to the line containing the opposite side of the triangle, which is AB. Let's get a point of intersection. Let's add a segment. I'm going to turn off the tracing line, and I'm going to turn this into a dotted line. And I meant to add, this is H3. And let's add H2. So here are the three heights of this triangle. And we can change it around to be more obtuse. We can change it around to be less obtuse. Can you see what happens to the heights as soon as I create a right triangle? And what about when I create an acute triangle? When the triangle is acute, all three altitudes land on the inside. When the triangle is a right, two of the three heights land on the triangle as legs. And when my triangle is obtuse, two of the triangles land outside on the lines containing the opposite sides. Let's mark these angles. Make sure they're 90. Where they meet the opposite side. And let's take a look again at what happens as they become, as this triangle becomes a right triangle, as this triangle becomes acute, and as this triangle goes back to being obtuse. The altitudes will remain perpendicular to the lines containing the opposite sides, whether they're acute, whether they're right, or whether they're obtuse. This is a big deal, so practice drawing this triangle by extending the lines and by using a note card or some other corner to ensure you have a perpendicular relationship with the opposite side.